We should be live in a second. Yay, good to go. Okay, welcome all. Hi, Pedro.
Hello. Hey.
Welcome. So welcome all to this event. This event is organized by Ethereum Magicians, and today we are going to talk about developer tools, especially on the layer 2. And Jamie will give you a quick intro of what happened last time on the intro session about the layer 2s. And yes, Jamie, the mic is yours. And then we will give mic to the speakers like Pedro and the rest of the developers.
All right, cool. So hi, my name is Jamie. And for everyone who's here, maybe you've come together with us at the Magicians, maybe last week or some other session. This series of sessions concern L2s and all the challenges ahead of us. These L2s have been with us for a while, ZK rollups and optimistic rollups, and of course all of the other kinds of solutions that are out there. And only recently has it become like very, I guess, prominently known that this is the way to move us forward. Even though it was becoming clear in the last 6 months, maybe even a year, that this was a viable path until Ethereum 2 is ready for smart contract deployments. And I think the key thing to remember about L2s, for just as a very brief introduction, is that they share security with Ethereum mainnet, and so there are more guarantees as a user and as a developer for what you're providing your users in terms of security for the smart contract or functionality that's deployed on an L2. And L2 of course isn't branded, and I think it sometimes is used, maybe assigned too loosely. But we can go over some of that in this session. In session 1, you can find it on the Ethereum Magicians forum. Session 1, we covered the real basics of L2s, and this session we're going to get into the developer experience and what it's like to deploy smart contracts to L2s, and like what might be difficult, what might be missing, but we'll really get into that. In the notes, like I have in the HackMD document, I linked to more documentation for each of these L2 options. If you scroll down in the document, you can see that I've listed out some of the top viable solutions. And this time I emphasize more about the documentation and actual, like if there's a language involved with the ZK rollup, or if there's any special thing that needs to be known, feature about it that needs to be known. I've linked to some of that documentation. So I think with that we can get started. And one key thing to remember is definitely ask tons of questions. That way, we can pick up on what you're interested in and what kinds of things you want to talk about. And two people we have here today is Pedro and Alex. And I'm not even sure which of you guys would like to begin, or if we could start getting questions coming in. But if I think if any of you want, we have Brian as well. If any of you would like to introduce the topic, or just open a discussion about what you think developers need, or if these L2s have sufficiently provided documentation, provided modules, libraries, all the resources developers will need. I did some research myself, and I don't think I'm ready to develop for L2s. I found some really good documentation examples, but I'm still definitely not feeling prepared for this at all as a lightweight developer. So I guess I'll turn it over to you guys. I think I'll just hand the mic over. How about I hand the mic to Pedro, because you're here first.
Cool, thanks. I mean, I think there's a lot of unknowns with the L2 development. Like you said, this is all very novel, and we've been kind of like thinking about scalability for like almost since inception. That's kind of like the point of this. We're developing more and more to kind of scale this to the use cases that people actually want. And one of the big problems is the block space is not sufficient to fulfill everyone's use case. Currently, rollups really are consolidating a lot of the use cases that we want, and there's primarily two big scalability solutions with ZK rollups and optimistic rollups. But then obviously each one of them come with their own trade-offs. And just like it's difficult for developers to get introduced into the L1 development, we're going to start seeing the exact same challenges for L2 development. And there's languages, there's going to be how to run nodes, how to connect to nodes, how to sign payloads to send to these nodes, and even how to even inspect these nodes. And ZK Sync has been quite interesting to see because it was used in the wild with Gitcoin, but obviously we're still simply talking about ERC20 token transfers. To get to the point where we actually have smart contracts on these L2 chains is not even within the next 6 months, I would say. But that's my opinion. Next, maybe Alex.
Yeah, Alex, you want to take a go, or I can go too.
Hello.
I'm sorry.
He's probably not hearing.
Oh, okay, he's probably not hearing us. Well, I mean, I can talk for a little bit. I think one thing that's important to talk about with these layer 2 frameworks is about use cases, like Pedro was mentioning. So I think we're going to see like a selection of use cases, and the ones that I think you can kind of broadly group them into are, I think the NFT ecosystem on Ethereum has a lot of need for this because of, transferring an NFT and it costs you $20 to move is not sustainable. And a lot of that activity will leave the ecosystem. We're already starting to see that. And then the other larger group is the DeFi ecosystem, which, as long as people can make money to justify paying those $20 fees, they'll continue paying those $20 fees. What's most important there is the access to the ecosystem justifies the cost. So you kind of have two groups that are a little bit opposing in terms of their use case and their like forgot the word, but like their propensity to want to pay these fees. And layer 2 will be easier to port over things that don't have the kinds of composable network effects that like the DeFi ecosystem has. So I've been really looking forward to NFT use cases to pop up on layer 2 as quickly as possible so we can kind of retain that ecosystem. And then probably the third group is simple money transfer use cases, which is kind of like the easiest, but if you can get it right and there's a business case for that, and businesses are being able to use layer 2 frameworks to do those kinds of peer-to-peer money transfers, then that's maybe a third group we can talk. So if Alex, if you're all set now, or maybe David, if you want to talk a little bit about framing the problem, I guess.
Sure. I'll see if Alex wants to jump in. But sorry, I joined late. Was there a question or just general thoughts on L2?
I think we're just kind of introducing ourselves, and then which I didn't do, and also framing the problems of the layer 2 ecosystem, and then we're going to probably more progressively get into the technical aspects.
Cool.
At least that's how I see it. Oh yeah, so I'm Brian. I work on the Viper EVM compiler, and I've been working on the YEarn system. Quite interesting.
I think you got cut off there. That means you've been working on it for.
I said like a month, so that's quite a while. And this.
Yeah, no, it's
most of the lifetime of YEarn. Cool. I guess I'll jump in. Yeah, I'm David. I think a lot of people might know me for I was very involved with the burner wallet stuff for a while. Still doing some of that, but I've got a few other projects. I'm working on something called DeFi 777. I've worked with the Fuel team quite a bit, building their optimistic rollup and some infrastructure around that. Yeah, and so in terms of problems with L2, I mean, there's been a lot of discussion around everyone looking at L2 and saying, is this going to kill composability? I just generally think there's going to be some very big shifts in the way applications are architected. You know, when we kind of go from this world of every application sitting on one layer 1 shard where everything is super interoperable, moving to a world where we have L2s and we have, you know, eventually shards on L1, but we have all this kind of fragmentation and asynchronicity. That's kind of one adjustment that I think a lot of developers are going to have to face building these applications. And I've got some thoughts on how to address it, but
that's a really good way to put it with those two terms. I think, yeah, that really simplifies and distills some of the pain.
Yeah, I think that's a great point. The cross layer 2 ecosystem is very underdeveloped, and it will only really be developed once we have use cases that are actually using the L2s directly. So like overall as an ecosystem, going back to my previous point, we have to think about in terms of stages, and like NFT is like a really easy stage because it's really just tossing it around and then, being able to interoperate with UIs and stuff like that. That's like a good first stage because it doesn't really require that interoperability yet. And if you really want to interact, an NFT with the DeFi ecosystem, you just kind of pull it back onto Ethereum for whatever reason. But as we get deeper into it and we want to port some of the DeFi architecture over to L2, we're definitely going to have cross-chain interactions, or not cross-chain, cross L2 interactions that are possible. And then something to look at there, I think, is actually Cosmos and Polkadot, and they're prototyping a lot of what it means for a cross-chain interaction to happen, and I think a lot of that work will actually port over to this cross L2 interactions.
One thing regarding NFTs is that NFTs become, I guess if we're kind of mainly looking at rollups, NFTs don't work super well on optimistic rollups just by the fact that the slow exit from a rollup is about, I think, 10 days on most optimistic rollups. And with fungible tokens, of course, you can kind of do an atomic swap to almost instantly move back to a main chain or a different L2. But with NFTs, of course, they're non-fungible. You can't just swap them in and out. So that's one challenge, especially since, I know there is some, I saw ZK Sync is adding contracts. Like there are starting to be some more verbose development on ZK rollups, but as of right now, it seems like optimistic rollups is the area where things can move more quickly in terms of smart contracts, and I imagine that's where you want to do more things with NFTs.
Oh, you mean in terms of like tokenizing the exit and doing the swap that way?
Yeah, in terms of being able to move in and out. If you're locking a NFT in an optimistic rollup, and you know that there's like a 10-day exit wait to move back to layer one, I think that's going to be a big challenge, and I think people are just generally not going to. Yeah, they're going to be a little doubtful about locking their NFT up for 10 days. Maybe not.
Yeah. So I mean, I said that because like really, if the primary use case is for transferring it around and using it in an environment where it's mostly about transfers, then you don't really need to exit the layer 2 for it to work. You can have like an application specific layer 2 system for going back to CryptoKitties, I guess. Like all the CryptoKitty action can happen on the layer 2, and really 98% of that doesn't really need to happen on Ethereum at all. Like that's not the point, right? The point is the game. Yeah, that is a good point. We do sort of need to group so optimistic rollups and then the ZK rollups, so they have a faster exit action because it's a validity proof instead of a fraud proof. But the limitations of the ZK rollups is that they really need to have statically determinable programs in order to operate because of how the zero knowledge proofs work.
I think like composability even doesn't, like, in my opinion, it's not even the worst part, because once you actually go into like these layer 2s, like the fact that you've even been able to like go that far, it means you have overcome a lot of issues that already come with L2 development, because composability is going to be an issue, but I don't think we're even there. Well, we're talking about interacting with different nodes that might not comply to the EVM interfaces that we're used to. We're talking about running nodes ourselves. We're talking about maybe using different languages in the case of like a smart contract on layer 2, like zkSync has Zinc, Starkware is having Cairo, Fuel will eventually also have its own language, and I think Arbitrum also has its own language. And I think only Optimism actually would come closer to Solidity on a layer 2. And all of these challenges come not only with the deployment of a smart contract on a layer 2, but also with building the user experience for these. Because we're talking about having users use their wallets with a completely different chain, which their wallets don't support, which will come with its own like friction. And even the way dApps are designed right now, I think one of the things that upsets me the most is that it feels very much designed for whatever MetaMask is on the latest. And that's reasonable given that MetaMask has taken like this kind of pivotal moment on Ethereum almost 4 years ago, where Ethereum was just barely unusable through a localhost 8545, and then the browser extension kind of just like shifted the UX for Ethereum significantly. So that kind of drove the UX for Ethereum for years. And finally, now we're starting to see some shift and some innovation in that aspect, where we are breaking apart from that kind of proprietary UX with like standardization in terms of how JSON RPC providers are developed, standardization in how you can actually build external functionality to wallets. They're not just about ABI encoding. And one of the things that I really would like to see, and I think what Cosmos and Polkadot are already preparing for, is the concept of a multi-chain application, where you're not interfacing a single network at a time, and you actually might have one or two accounts in different chains connected. And I think that's also very relevant for a L1, L2 application that not only lives on the L2, but also has some context over the L1. And that, in my opinion, will be a huge design change for a lot of these dApps that exist right now.
Are there examples of how they're already doing that? Like, I know Bryant already had mentioned that Polkadot is kind of blazing a trail toward this sort of thing, which I was kind of surprised to hear. Are there examples of dApps that they have integrated this concept well?
I think like most that I've seen focus very much on the staking user experience, where you're managing staking in different networks. But even then, even if it's a very elementary functionality, it does have this like contextual of multiple chains at the same time. There isn't this like pattern that we have very much on Ethereum where, hey, switch network because it has to be only one at a time kind of design. And having this idea like you're staking for this one, you're watching governance for that one, and you don't have to have this switch. You almost have like this dashboard into your blockchain world, which I kind of want to see Ethereum applications go in that direction. And I think the reason Cosmos and Polkadot headed there first, not only because they appeared later than Ethereum, but also because they appeared with this assumption that the chains are not going to be homogeneous, which in Ethereum is very much the case. No matter if you're talking to XDAI or to Ethereum or Ethereum Classic or POA, all of these chains are EVM compatible. And there is this assumption of a single interface and virtual machine that you do not need to take into account different design patterns. And on Cosmos and Polkadot, we see more a concern about taking in different interfaces and execution environments because there's no assumption about how one chain should interact with the.
Well, there is kind of an assumption that it's going to be a WASM based like binary, but yeah, I definitely see the point you're trying to make there. As far as like Cosmos versus Polkadot, I think Cosmos is a little bit ahead on this because they've been prototyping their IBC for a little bit longer. But from the UX perspective, I think that is the more challenging aspect to this, and being able to get a wallet to work in a multi-chain kind of multi-framework future is a really big challenge. I just wanted to make one clarification though with Zinc and Cairo. I haven't been following all of the layer 2s, but I've been following some of the ZK roll-up stuff because I'm interested in it. So Zinc and Cairo are transpilers for the EVM. So they're mostly compatible with EVM languages. So that, like Zinc, for example, is actually a Solidity transpiler that can recompile a Solidity program if it meets certain qualifications. And they actually, for Viper, they actually been able to port, one-for-one curve over just because of Viper's more limited assumptions around dynamic types and how there's limits to those types. So that's one thing to note. And the OVM is actually a transpiler itself. It will actually, take in Solidity code and change the EVM code to OVM code. Nick, you didn't really get a chance to talk yet, so why didn't you?
Sure. Yeah, I'm Nick. I lead engineering for Truffle. I'm mostly here to kind of get a sense for where the community is at. But to state kind of what I'm most interested in, I would say it's the composability aspect. I'm very interested in applications that can easily go from either an L1 to an L2 or from one L2 to a different L2. And so these languages that target the EVM, or if everything targets EWASM, like that future is very interesting to me, because you can take your application, maybe CryptoKitties, that was on an L1 and needed to go to a different network, and that should be very seamless. And then the interoperability aspect, I'm very curious what Ethereum 2 will have in store for that, because Ethereum 2 is going to have to deal with multiple shards. So we're going to have this problem of communicating, essentially to a different blockchain or to a different network. And I'm very curious to see what languages will do to support that. Like, will Solidity and Viper get an await keyword, for instance? And then, yeah, I'm very interested in the user experience. Like, swapping networks in MetaMask is not a sustainable solution, but neither is having your application run a server which stores the private keys. So, yeah, I don't necessarily have insights on these matters, but I'm curious what the discussion will hold.
I was thinking of like a good like analogy. I think like the cross shard interactions are kind of more like threading, and the cross like L2 interactions are more like async await, like what's the word for that? Coroutines.
Well, in computers, there's processes and threads.
Yeah.
So I guess one would be like a process, one would be like a thread.
Yeah. Well, I was thinking more like you can have coroutines, which are usually intended to be like a longer term interaction where you're waiting on a server to respond to something or something like that. And then you have threading, which is like it's actually doing a parallelism, but it's usually a much tighter time framework. And I think that the cross shard interactions are going to be more in that kind of threading path where the underlying virtual machine will have it'll either have an API for being able to interact with the shards, or it'll be almost opaque to the user. Whereas like the cross L2 interactions, if a language supports it, a higher level language like Viper Solidity, you would have to kind of consider how those interactions bridge, and that would have to be in the user.
Yeah, and there will need to be new standards for that, right? Because let's say you're interacting with the Solidity contract, and then you have a Viper contract on an L2. Something inside Solidity is going to have to return a result that the user is going to then be responsible to transmit to the L2.
Yeah, like not the user, but like the
right, of course, the user, the computer.
Yeah, the whole notion of transaction, that seems to be challenging in this scenario, and that's I think this is a really interesting topic. This like what is the notion of composability? It's become a practically marketing term now, but I think it needs to be defined very clearly in a technical sense. How is the notion of transaction preserved in this scenario when there's L2 to L2 in particular? I think that is actually the one that I'm uncertain about if it's even possible to have a notion of a transaction in that scenario.
Well, back in Web 2, in microservice architectures, there's a concept called a correlation ID, which ties together multiple interactions. So I imagine we might see something like that, but I don't know who would be responsible. Would it be on an application, like for a multi-chain application? I guess that application would keep track of these correlations.
Yeah, I mean, it would probably be more like you have like the layer 2, layer 1 system, right? So you do a layer 2 transaction, you wait for the layer 1 sync to happen, and then that's like you're moving from like committed to confirmed. And then with like a cross L2, that's another addition to that, and you might have like the way an atomic swap works is that it either both sides commit or neither side does. So you'd probably have some sort of like, okay, well, first you submitted the transaction, then it confirmed, then it went, it was able to be synchronized with the L1, and then you see the atomic swap actually complete with the other L2. So you're kind of like building a pyramid structure up and down. And then, so you would have to have, I guess, for transactions, the concept of like multiple stages, and being able to represent that in UX frameworks. But I think, there is a lot of complicated interactions here to think about.
It's almost like the ABI needs to define a state machine or whatever interface is used to document these applications. Right now, the ABI just describes individual functions and events. But when you're dealing with this multi-network sync, like sync back to L1 and then relay to L2, you need to keep track of, okay, this function is just the first part, and then it leads to a flow with this function. And that doesn't seem like a very easy problem.
There was a standard I recall from the earlier web eras about it was a composition type of framework that described what happens to multiple systems processing something. I'll see if I can dig that up. Some ancient history. I think it was here.
Nice. If we're talking in terms of like standardization, it really does seem like a lot of these layer 2 frameworks and, of course, our entire ecosystem standardized around the EVM. And it doesn't seem like that will change. So we'll have to, think about how we expand these UX interactions like the ABI, like you're saying, in order to accommodate, the notion of layer 1 and layer 2, the notion of cross layer 2, atomic swaps, different technologies like that, that enable, cross layer 2 swaps or cross layer 2 interactions. It's very interesting. The ABI thing I didn't think about until you.
So one thing you mentioned there is you said kind of that you think there's some standardization around the EVM, but as Pedro mentioned before, like lots of these layer 2s, outside of Optimism and maybe a few, lots of these layer 2s are building their own virtual machines, their own languages. So do you guys think that?
I responded to that previously. So like Zinc and Cairo are actually EVM transpilers. So they actually are kind of EVM based. And the LVM.
Well, at least I know, working with Fuel, like they're working on their VM and a language, and it's not going to be, I'm not sure what they're looking at in terms of transpilation, but it will have like its own language and its own virtual machine. And I guess they're seeing it as a way of differentiating. But do you guys think that kind of this system of heterogeneous chains, heterogeneous VMs, that poses challenges?
I think for a developer perspective, it is difficult to kind of consider multiple backends. I mean, multiple architectures like that, and they would prefer a compiler to add backends to be able to switch between those. So you can have something like Solidity or Viper, and you give it a flag like compile for OVM or compile for Zinc or compile for Cairo, and that's really what the developer experience should be in order to make this easy for them. And that's ultimately the reason why I think the EVM is turning into this kind of like ecosystem-wide representation that is being used for a lot of these layer 2 frameworks. And the fact that like a layer 2 framework like Fuel has a language doesn't necessarily mean they have a language like Solidity that's meant for users to use directly. It could be an intermediate language that's meant to use for transpilation to their particular framework. Because all of these layer 2s are going to have different virtual machine architectures that are not the EVM, but we have to figure out how we, as tool developers, we have to figure out how to translate that experience for the developers.
Yeah, that's the interesting problem, isn't it? Right? Because it might take you 3 to 6 months to develop a dApp, and then by the time you're done, the gas price on Ethereum has tripled, and you realize, oh wait, I better use XDAI. Or if these layer 2 frameworks, find success, you would switch to those. But from the community perspective, not zooming out from the developer perspective, I think the interfaces between applications becomes of paramount importance, right? Like, it's not just a question of how do you write your program, how do you write your smart contract? How does your smart contract know that it can talk to other smart contracts on other networks?
That's an excellent question.
You mean as a developer?
Well, I mean,
Or the user also. The user is like, what is going to happen here?
Right? Like, there's the risk that it all becomes fragmented because there's no standard interface for communicating across smart contracts. Like right now we have the ABI, which is great. This is one of Ethereum's best features.
So for me, for Viper, I was thinking about this ecosystem, and as it comes more into play, being able to write a Viper contract that you can basically define certain chunks of the functionality it has as being like in a layer 2 framework versus as being on Ethereum. So you'd write this program that says like, well, this action is on Ethereum, and this action is on this layer 2 framework, and this action is on another layer 2 framework. And the compiler can basically handle like, oh, well, linking together this action to that action requires like a deposit action to occur, or linking together. I don't know how I would do the cross layer 2 ecosystem as well, but like you can think of like there's a particular style of connection, like an atomic swap, and that links the two together. So yeah, it's a very interesting problem, and obviously I haven't thought through it as deeply as we needed to
that
be.
simplifies it quite a bit, though.
Yeah,
Like,
having the developer
using atomic swap, I think that is like a little kernel of grounding that helps a lot.
Yeah. We will have to, like, we can standardize languages, but languages aren't really the issue here. The mechanism for doing that action, that cross layer 2 or cross chain action, is the issue, right? Even if you have a side chain like XDAI, like what's the action to get you from that bridges you from Ethereum over there? And that's the same stuff that like Cosmos and Polkadot are developing, because they have to figure out like cryptographically secure interaction technologies like atomic swaps and other features like that get you from one chain to another without like being able to be gamed. And so like one side will be dropped and the other side is left holding the bag. Like you don't want that. Yeah, I think a good example of a cross-chain atomic swap is what TBDC is doing. So, that's using
what's that one? Say that again.
TBDC. That's what the Keep network folks have worked on.
Okay, yeah, Keep.
Yeah,
so that's too many.
They basically have a Bitcoin like block processor on Ethereum in a smart contract. So basically the Ethereum side is handling the state machine around how blocks get updated on the Bitcoin side. And just they have like, I think, a configurable block limit of like 6 blocks that you have to wait for, because like a 6 block reorg is like pretty rare, and for it to happen in Bitcoin, that would be pretty difficult.
Brian, did you say you had a spec for that for Viper?
I have an idea in my head. I've been really waiting for these layer 2 systems to get a lot more traction before we approach that problem, because it's so ethereal to think about that problem and how we could solve it. But for as far as like a spec, I think there's a Viper VIP. I'll go on mute and.
Yeah, I'd be very interested to read anything that you've.
So I think that it just might be me with time, just getting more and more pragmatic. But with anything new, we always try to solve every problem, and then eventually we get tired, and we eventually try to solve at least one. And if you look at Ethereum with its infinite, almost Turing complete smart contract blockchain ecosystem, we could basically shift the whole world on how it works. But we did end up doing was one thing, and it was really good at, which was tokenizing. We just tokenized everything. Tokenization is by far the biggest feature of Ethereum. And we see like even more complex systems, and now it's not even considered complex, like for example, Compound, where they had these money markets for lending and borrowing between two parties, tokenizing the debt itself, which made the transfer of this complex system into another system much easier. If you were to do an integration between another system, let's say, I don't know, synthetics or Aave, all of these DeFi protocols, they all have their own design mechanisms in place. And it would be much, much harder to take into account how Compound would work if Compound didn't create like a C token. And the C token has like these assumptions about the protocol that you can basically translate into an ERC20 token, which is basically the minimum common denominator between all of these DeFi protocols. So I feel that like while there will be a future where cross-shard, cross-L2, cross-chain call data can be as arbitrary, as generalized as possible, we will start at the token level, where the representation of some state on one protocol can be transferred to another through a token. And we can focus on this composability at a simple fungible token transfer. And I think that's kind of the starting point for a lot of these composability systems, because atomic swaps are doable today.
Yeah, that definitely aligns with the way I've been thinking about layer 2 and kind of feeling like some of the worry about composability on layer 2 is a little like, I don't know, I'm not as worried about composability because I guess of these settlement assurances. I think some people are thinking that there's going to be like one layer, we're going to pick like the perfect layer 2 and we're just going to like copy DeFi and we're going to, every application on Ethereum is going to run on Optimism now. First of all, that doesn't actually give us any scalability, but second of all, like if you want to, say in the example of Compound, if you have DAI and you want to lend that DAI and earn interest, right now on layer 1, you would deposit that DAI into Compound and it would mint you CDAI. But if you're on a layer 2, you don't necessarily need to actually deposit an asset in some smart contract lending protocol. If you have someone that's willing to trade you CDAI for DAI, then you've essentially just deposited your DAI into Compound. And especially, if layer 2 is going to be kind of the layer of the small fish, the individual users, where people can put $10 into Compound, you can do lots of those like atomic swaps very cheaply, and then some liquidity provider can kind of take their CDAI back to mainnet and convert it into DAI or whatever, do these more complex transactions. So to me, that's, I think, kind of the shift in thinking, that not every transaction needs to be actually running through these complex virtual machines to execute what the user wants to do. There just needs to be like this settlement assurance that if I am holding CDAI, I know I can settle that for DAI on layer 1, even if the Compound infrastructure is not on layer 2.
I think that's a really interesting point. The tokenization is like a UX technology in a way. It's like it's a way to conceptualize the settlement assurance as like an explicit token. And so one thing I was looking at into recently is this thing called LidoFi. And what they're doing is they're actually going to tokenize the the beacon chain deposited ETH and the rewards and slashing penalties into a token called STETH, and that's going to live on the current mainnet Ethereum, and that will, I mean, that's a representation that's actually legally binding, and not, I mean, there's obviously cryptographically binding in some way, but it is really a legal innovation there too, which is interesting to think about in terms of like its settlement assurance of you being able to obtain Ether on ETH 2.0 when we have like phase 2 is enabled and transfers are enabled. It's basically like a deposit slip for that event. And then it's been tokenized so that you can actually continue using it on layer 1 while that bridge is being finalized, basically. So that's a really interesting point about tokenization and how it can be used to solve problems.
I love the idea of token as interface. It's really quite clever. But question about other kinds of applications, like how does it work for games, right? If you have some computer game or some blockchain game that runs on an L2 but settles on L1, you can't just have tokens for every possible state, right? If I make a move, if I'm playing chess, right, and I move my bishop, is there a bishop to C3 token? How does that look? Or what does that look like?
Well, I mean, so the move wouldn't be tokenized. The move is like a transaction. Maybe the piece could be or something, but like the point of the layer 2 frameworks is that they actually summarize those actions that are occurring on layer 2. And like the end effects of those actions, like where a piece might be in a game, or like who owns what in their inventory in like some sort of RPG game or something. It summarizes all of the actions across all of the people in that ecosystem into one summary statistic that is available on layer 1 when it's settled through the synchronization process. So if there was a way that, or if there was like a condition where somebody wanted to actually pull it out, they only need to do that action on layer 1 of pulling it out. They're not actually replaying all of the actions that happened inside the layer 2. At least in most cases, the point is to avoid that. That's the point of the layer 2 system.
One thing to consider too is which type of actions actually need to be able to be settled back to layer 1. Like obviously valuable assets, your tokens, your NFTs, you need to be able to be sure that those can settle. That, you know, if there's an issue with your L2, if someone's trying to do fraud, or if the chain shuts down, you can move those back to mainnet. But I'd say for something like a game, oftentimes you don't actually care. Like you don't need to save your game state back to L1. If there's an issue, you want the assurance that you can kind of maybe run your own node, and if you have money in this game, like withdraw it. But you know, if you want this state of a layer 2 to be settled back to an L1, and it's not a token, because obviously every layer 2 will allow tokens to be settled back. If you have more arbitrary data that needs to be settled back, that's when we start talking about kind of inter-blockchain communication and more complex systems. But I think that's going to be probably a small set of applications that actually need that, because as I said, like assets, financial assets, you know, every layer 2 will allow settling those. And some applications, again, like games, it just won't matter if you can settle it back. Nobody wants to take the state of their chess game and put that on mainnet Ethereum.
That's a good point. So I guess my concern really isn't practical or important. Because yeah, what you'd want to settle is the result of the chess game, right?
Yeah. I mean, I think it is important, and I think it will have a place, and there will definitely be applications that need to take advantage of it. I just don't think it's going to be all applications. I think it's probably going to be a subset, a relatively small subset that need to be actively communicating between their layer 2 and their layer 1 in a way that's not just moving assets.
So this is quite interesting because when I was working with Connext on state channel infrastructure, they took the counterfactual framework, which was published by L4, and they built like a very complex system to execute it. And they had SDKs, they had servers. They basically tried to ensure the user experience was as best as possible for this generalized state channel framework to work. And what was very clear at one point was that it could all be very nailed down to one use case, which was ended up being conditional transfers. So while there are multiple types of conditions for a transfer, there were multiple interpreters for to be resolved on chain, but there was only one that was actually used for almost all use cases, which was a single asset party to party outcome. So there would be two parties in a system that would have a transfer of an asset, which would eventually, even if you had a chess game, it would basically mean two parties locked some amount, and then one of them won and got all of the amounts. And it didn't even matter what it was that was happening off chain. It just mattered that you actually could resolve that outcome. So you would be able to sign these outcomes in state transitions, but you just needed the on-chain interpreter to just interpret whether or not party A or B got the price, in a sense, or got the asset from that off-chain interaction. So it's not so much that you don't want to like save the state. It's also that you don't need to save the state of what happened off chain, but it's more like that eventually all of the outcomes do you actually care is who gets the balance at the end. And that kind of solves like by a token transfer.
Right. So then we're just back to tokens for everything, which is great.
Yeah, because you basically, just to finish off, it almost feels like a token transfer to an escrow, and then it feels like a token transfer to the winning party in a sense, or it's not so much a winning party as more of the final state party that actually gets the balance.
Right. What was the technology that you mentioned that pioneered these conditional transfers? I missed it. Sorry.
Oh, sorry. So Connext built Indra, which is based on counterfactuals generalized state channels, and now they built Vector, which is based purely on a single interpreter that only does conditional transfers. And they were actually able to complete the protocol much easier because of the reduction of complexity that came once you actually narrow down the scope of use cases. So essentially, Vector is not a generalized state channel. It's more like a payment channel with multiple conditions, while normal payment channels like the Connext V1 actually had a single condition.
Oh, very cool. Yeah, thanks for that. I'm going to look into that.
And another learning that came from my experience working with Connext was that it was also very relevant that maybe state channels, although their use case is a peer-to-peer micropayment, it would be more useful if these peers, so to speak, are more like machine to machine. So it's not necessarily a user-facing technology as much as it is between transferring assets between two systems. And that was kind of at the Ethereum scalability bake-off on Reddit. That was kind of like the use case that we saw, which was not so much that the state channels could provide the scalability for the users, but it could provide the token transfer between two heterogeneous systems, like, for example, between XDAI to Optimism. And you could just have that token transfer done very easily, given that a user is actually interfacing with a liquidity provider who's actually able to transfer fungible assets from one system to another.
You brought up liquidity providers there. I think that's an interesting area to discuss because I think that's going to become very important. You're right now on layer one Ethereum liquidity providers, they kind of basically provide liquidity on automated market makers, but with layer twos, with optimistic rollups, you're going to need liquidity providers to move your assets between the layer 2 and to kind of have this fast withdrawal. As you were talking about, if you want to move assets between 2 different layer 2s, you'll need a liquidity provider to give that atomic swap. And also based on what we were talking about, kind of tokenization before, there will need to be these liquidity providers that are kind of like syncing the state between layer 1 and layer 2, I guess. So if the price of CDAI on layer 2 is off from the price on layer 1, there needs to be a liquidity provider that's going to kind of rebalance those prices. So I was just curious what everyone thinks about, I don't know, is there going to be enough liquidity? Is this going to be very fractured liquidity across this ecosystem? And will chains struggle to gain that liquidity, since it seems like that'll be an important part of any usable layer 2 solution?
This is a great point to bring up. I think I had been confused about the role of liquidity in atomic swaps or cross-chain interactions, and now I'm starting to actually see the light on it. But I'm a bit new to DeFi in general, but it's fascinating. This actually becomes an underlying technical, economic type of requirement.
And it's an interesting challenge we talked about at Fuel a lot, because in some sense, these liquidity providers, it should be a good opportunity, because they're in some cases, it's basically no risk liquidity providing. It might be some time cost. So if you're exiting an optimistic rollup, some user wants to take their DAI from a layer 2 to a layer 1 right now, liquidity provider will say, like, well, I'll give you some DAI today in exchange for your layer 2 DAI, which will take me 10 days to withdraw, or maybe they can kind of provide 2 sides of a trade and break even. So it's kind of low risk for them, which means that the fees should be relatively low. But again, if the fees are relatively low, I wonder if these projects will just struggle to attract liquidity providers in the first place, especially if providing liquidity is a more active process. If providing liquidity on Uniswap just means sticking your tokens in a pool, but providing liquidity on layer 2s might mean that you have to run a node that can kind of respond to requests.
I mean, it's kind of like a chicken and egg situation, right? Like, why would liquidity providers even exist if there isn't enough users to actually make these exits and withdrawals or cross-chain transfers? And I think that at the very beginning, just like as we've seen with ICOs, I can see that there will be kind of like this design with the liquidity mining where you want to provide a good user experience to your users. So if you do build an application on a layer 2 system and you don't have the sufficient liquidity to actually provide a good user experience, because for example, let's say an MMM like Uniswap on a layer 2, without the liquidity, it would just have terrible slippage and it would just be useless for anyone, no matter how instantaneous those swaps would have been. So I can see liquidity mining, is it liquid? Yeah, liquidity mining on a L2 being designed into a protocol to drive liquidity providers to provide a good user experience for the users. Because what is the advantage for me other than saving gas costs to go to a layer 2 AMM, but then the slippage is terrible because there's not enough liquidity?
So it seems like I like the point about the liquidity providers have to run their own nodes, and it seems like that should be avoided. Like, is there a way that we could have networks that kind of like bridge networks that operate between the L1 and the specific L2, and kind of have their own smart contract so that liquidity providers can have like an easy entry into the system? I don't know if this is too much, but perhaps I'm just thinking perhaps there's a solution where you can have a generalized bridge so that people don't have to run infrastructure.
I think one problem is that any bridges generally need operators. So some of the existing, like XDAI has a bridge, but this is just basically a multi-sig. It's like almost a little bit custodial. To do like real atomic swaps, you need to kind of have this secret, you publish a hash and you have the input to that hash, which you keep secret. And so this all has to be maintained off chain. I was wondering, Pedro, if you had any insights, just again, working with Connects a bit in terms of how we can make this bridging and liquidity providing as easy as possible for liquidity providers.
I mean, with Spacefold, it was actually quite interesting because that was kind of like the main struggles. It was actually having these node providers to actually build, because the way that the Connects system was built was for EVM compatible systems. So that wasn't so much of a worry. It was actually running the nodes or having access to node operators that was actually the biggest struggle. And we would see issues where users would complain that they didn't do an atomic swap, and it was actually one of the node providers was unavailable or something. So maybe this is just as Infura came into existence as a sustainable business for providing infrastructure for L1, there could be this kind of like relayer service into multiple L2s that you actually not only maintain operation for bridging, but also for accessing these layer 2s that you might. So I guess this is where Cosmos really shines, where this ecosystem has really thought about this not only heterogeneous system of multi-chains, but also the fact that you might not be running the other system, but you need to interface with it to, let's say, evaluate the provenance of a token. We were saying about the C tokens on Compound, you would need to actually interface with this other chain to actually prove that the liquidity of this token has that depth associated with that amount. So how do we actually, are we going to run nodes for everything, or are we going to use some services, or maybe we just run nodes for the ones that we find more relevant to our use case, and then just sporadically connect to some remote nodes just to give some provenance about some data that it's related to that token transfer. So I think this is where businesses are really going to shine into kind of providing flexibility for applications to build on top of these multi-chains.
There's a comment in the live chat. So
I mean, when it comes to rebalancing, I guess you could also see that even within DeFi protocols, there's a lot of arbitrage opportunities, and we're seeing people dedicate themselves in doing these. So I think the economic incentive is just trying to shave off those profits between them, where people who actually have the capital to actually take advantage of these arbitrages are actually going to be deploying this capital into multiple protocols in an attempt to be the first come, first serve for those arbitrages. So I'm not sure if the design needs to be there to create the economic incentives for the LPs, because the profit between one system or the other, it already creates this opportunity. And we've seen this even within centralized exchanges because of the low liquidity that it existed. And some people professionalize themselves into taking advantage of these arbitrages between centralized exchanges. And now with this DeFi craze, we're seeing the same thing happen at the decentralized exchange level. So I think the incentive itself is on the arbitrage that exists there.
I talked to a friend who was trying to kind of find some economic opportunities in decentralized finance and crypto, and we kind of were talking about arbitrage. And I imagine most arbitrage between decentralized exchanges and automated market makers, like that's probably already captured a lot. But what I was kind of saying is there's going to be a lot of opportunities in arbitraging across layer 2s and layer 1s. And it's going to be a little more capital intensive because Flash loans, for example, don't exist for cross-chain, cross-shard, cross-layer 2 trades. So if people are using it, if those economic opportunities exist, it should attract people. People are always looking to kind of find pennies that they can pick up off the ground and make a couple million pennies a day.
I guess as a wallet enthusiast, to say the least, like how do wallets actually fit into this development? Because we are seeing a lot of these L2 systems bootstrapping on, for example, taking a message signature and just using that as entropy for a burner wallet on a browser. And that's how ZK Sync works. But this is obviously not sustainable. While there are different trust assumptions on a layer 2 chains, I think that making the assumption that a simple signature entropy wallet on a browser would be sufficient. And I think that we're going to see first the friction at the dApp level, but then if users really want to feel confident about putting some funds into these layer 2 systems, the wallet infrastructure will also have to develop to support these layer 2s.
And what do you see there? Is it just connecting and facilitating for the user what's happening, or are there other issues? I guess what I'm asking is, what are the main things you see, main gaps you see here?
The first thing is obviously, as I mentioned before, this change that will have to come. It's just inevitable that applications should not make this assumption of a single chain and should also become multi-chain or multi-chart or multi-system. Maybe that's the better word. Like they have to make, for example, I really like to use a very simple example as the XDAI bridge, because I think as a user, it doesn't seem reasonable that if I'm making a bridge between XDAI and Ethereum, I have to make a transfer to the escrow and then a claim on the other side. And there isn't even an automatic switch, or at least a context of both chains at the same time, that you actually have to switch your wallet to then make a claim. It would be much more reasonable for the application to request this transfer, and as soon as it meets the minimum block confirmation requirement, it would make the same request to the XDAI chain or the Ethereum chain, depending which direction you're going. So you can see how something as simple between two EVM systems is already kind of a nuisance. And with layer 2s and heterogeneous chains, it's just going to be more complicated. And wallets will have to adapt this. It's not just a matter of connecting to a remote node. It's also about applying the UIs to actually translate these transfer requests into their systems, and obviously connecting to applications and interpreting interfaces in that aspect.
Yeah, XDAI is such a great example because just even the naming, how MetaMask treats XDAI, it could be so very confusing for users. Like, what is the cryptocurrency of this remote network? How gas works, how you pay for things. The way MetaMask depicts it could be very confusing. I
really wish MetaMask would make XDAI or just other chains in general easier, because most of these chains, like, they're like, hey, like copy and paste this, you have to fill out this form to use another chain. Like, it should be a one-click thing.
So earlier,
there has been standards proposals for that.
Just not adopted yet. Sad.
So earlier Nick said, I think it was Nick, that it would be nice to have like a kind of like a transaction package which describes all these different interactions which need to happen. I guess that's like one way to do it, but the simple way of today, just sticking with this example, is that the Ethereum API, and what is it called in the browser? I just can't remember the EIP term. But anyway, that doesn't allow multiple connections at the same time. And if it would allow multiple connections, and you would tell which multiple networks you want to connect, then all of this can be handled on the dApp side. You don't need anything complex like a transaction package, which tries to encapsulate every possible interaction with any kind of chain.
So would that tie everyone to the JSON RPC?
Well, each of the different chains or networks have their own browser integration, right? I mean, Ethereum has this agreed protocol as well, and then multiple JavaScript libraries would implement it, and multiple wallets implement it. But I guess other chains, they may not be as sophisticated as this setup yet, and they rather just have like a single library in JavaScript. And if you're using those chains together with Ethereum on the same dApp, there's no conflict between those libraries and the Ethereum side. The conflict right now is if you're trying to use multiple Ethereum-like chains.
So as a proud JSON RPC maximalist, I feel like I should intervene here. And I definitely feel that everything should be JSON RPC, because it doesn't necessarily mean that the actual nodes actually have to have these JSON RPC interfaces. But JSON RPC is a much more flexible system to design applications, simply because it can be proxied through multiple messaging protocols. Obviously, I would love for everything to be, for example, gRPC, but that's just not feasible for both mobile and browser applications. So that would be basically set just for a desktop process or a server. So what I see right now is, for example, just talking about Ethereum, the if send transaction JSON RPC method already comes flawed by default, because it was designed before even chain IDs existed, because the if send transaction in itself should include the chain ID, because the actual signature that's going to be returned will need this requirement to actually format the RSV parameters of the signature. So I think that was just a design flaw as Ethereum learned different things and as the first fork happened. But chain ID should have been at the if send transaction layer already. But since this is not the case, and I think it gets more complicated to actually change patterns that exist as of today, I think that it's important to create these JSON RPC providers that interface between wallets and applications to actually have this intent of targeting a specific chain. So you could have a wallet that uses both Ethereum and XDAI and exposes accounts for both, meaning that the application would be connected to both chains simultaneously without needing to actually request the user to be switching networks depending on which interaction is going to have. And then on the moment of requesting a JSON RPC request, it would simply include a target of the chain ID. So if the user is doing an XDAI bridge, it would expose both accounts for Ethereum and XDAI, and it would have chain ID 1 for Ethereum mainnet and chain ID 100 for XDAI. And then whenever it actually wanted to transfer on Ethereum mainnet, it would include the chain ID 1. And whenever it actually wanted to do a claim, it would actually include the chain ID 100. And I think this is a very simple change on interface that not only would make multi-EVM wallets easier to design, but also a multi-chain world easier to design for both heterogeneous chains that include Cosmos and Polkadot, but also rollups like Fuel, Optimism, and ZK rollups like Starkware and Validium with, ZK rollups like ZK Sync and Validium with Starkware. All of this complexity can be reduced to simply having this clear intent from the application to actually target a chain instead of making an assumption of a single chain.
I would love if those JSON RPC endpoints, I guess, or function types included that chain ID. I had to deal with that so much for the burner wallet, trying to deal with kind of providing information for both XDAI and mainnet Ethereum or other networks at the same time. One thing I just wanted to kind of bring up as you were talking about being a JSON RPC maximalist is the differentiation between JSON RPC, just the general protocol, and the like Ethereum JSON RPC standard. Yeah, I mean, JSON RPC is great. I think there's kind of not a
because that's Ethereum JSON RPC API, which is the specific set of methods to interface with the Ethereum chain. But obviously, when I say I'm a JSON RPC maximalist, it's the specification of how to actually execute methods remotely.
Yeah. So I think that's a good differentiation. I'm guessing that you were talking about just JSON RPC in general and not the way Ethereum has constructed their...
Absolutely not. And actually, I think that a lot of people did it very wrong. Like, I've been in touch with a lot of systems where they actually wanted to be so compatible with Ethereum applications that they took those methods as is and then included their own changes because their systems weren't necessarily the same. So they would have the exact same method with different parameters or different results. And that basically breaks the whole pattern, because if you're going to do an if send transaction, you should expect always the same behavior and the same parameters. Therefore, if you were to change these, you need to create your own methods with perhaps even the same method name, but a different prefix, where we can create a more JSON RPC method plurality, but at least a more specific like behavior for each method. And that actually is very important to actually expand instead of repeat what Ethereum did.
I think that would make a lot of sense if we could, in terms of Ethereum specifically, if that almost seems like kind of the upgrade path. If there could be a JSON RPC 2.0, and the clients could kind of check for the existence of newer methods and fall back to the old kind of flawed ones if they don't exist. That would make a lot of sense. And I think this is just kind of a challenge in general for these layer 2s to figure out their level of compatibility. I know with Fuel we talked about, everyone wants to be as easy to like plug and play their layer 2 into Ethereum as possible. And so even though Fuel's architecture looks nothing like Ethereum or EVM, we talked about kind of building a JSON RPC endpoint that would, you could kind of send these like ERC20 transfer calls, and Fuel would handle those as normal token transfers, even though you're sending this data field with it's like a function call for a transfer. That's not actually what's happening in Fuel, but this would give you that plug and play. But again, this is the trade-off. Do we want to? How much should newer systems kind of like bend over to try to act like the way Ethereum's acting, and how much should they push their newer standards that maybe are a little cleaner, make a little more sense? And how much should the whole layer 2 ecosystem in general try to get together and standardize new protocols and force wallet developers to adopt them instead of using what wallets are?
Personally, I think that layer 2 systems should not use the same methods as Ethereum. They could mimic them, but you would have, for example, Fuel_send transaction, which would look very similar to the if send transaction, but not the same.
So it's not just a question of adding chain ID to the parameters.
Yes, I would say that we have this context of a chain ID, which is about the system that we're targeting, but also a context about the methods that we're going to use. You could use if send transaction if I did the exact same parameters, and I would always get the same result. And this happens between XDAI and Ethereum. It makes sense to reuse ETH send transaction because there are basically a protocol fork. But in the case of, no matter how close the transpilers are for Zinc, Cairo, and Optimism, they are different systems with different opcodes, which will have different outcomes for this execution. So at that point, I think it's reasonable to change the method.
So then software needs to exist to delegate to the correct method or to delegate the chain ID. And this just starts to seem like a very interesting tooling problem.
Which is exactly what I'm working on. That's why I'm so excited. I call them JSON RPC authenticators.
Oh, interesting.
Yeah, I was publishing a few updates before this, so I can show you.
We want to go through some of the get some questions in the chat.
There was something I wanted to bring up, perhaps before we do that. For ETH2, like they have defined a new type of JSON RPC. I believe it's REST. Am I correct? Has anyone opened these up? I was looking for what they're doing with JSON RPC if they're implementing it.
Well, what I understood was done was that it's still possible to use JSON RPC, and there are some newer methods because the beacon chain has different parameters than the proof of work chain. But what happened was that they saw a demand for having an exact mapping of these JSON RPC endpoints into a REST API. But they are a one-to-one map, from my understanding. But I could be corrected. But I think both of them exist in parallel.
Okay, nice.
Yeah, I pasted the link to that repository.
Here's one other kind of thing while we were talking about wallets. One new challenge for wallets and for layer 2s in general will be kind of private keys and signature management. Because while some, especially optimistic rollups, will support the same signatures that Ethereum supports, some of them are trying to use BLS signatures. There's ZK rollups, which we're using some other crazy kind of signatures. So this requires having more signatures per user. I think a lot of these like layer 2s right now are solving this by like the user generates their private key like every time they load the application, but that's certainly not an elegant solution. So yeah, one new feature for wallets will be like our wallet's going to have to juggle a lot of different private keys and signature types.
That's kind of like the whole point of a wallet, is to deal with that. That's why applications don't develop wallets, because there's so much work to be done on the cryptography side. But they delegate it to wallet applications. I think the most important thing when it comes to the interface between applications and wallets is I feel very strongly about these methods to be as explicit as possible, because it also solves, in my opinion, this issue with different signatures. Because if you were to have a different signature, you should definitely expect a different method, because you're not supposed to be signing a 256K1 signature for ETH. You should expect a signature that matches the RSV encoding with a 256K1 curve for the ETH transaction. And if you're going to use BLS, therefore you should have a completely different method, because then the application will be able to recover that signature accurately because it used a different method.
Are these differences clear to a developer? Is it currently these
Like signature
like,
differences?
for example, in the type of signature used, the type of cryptography used in a signature, like, is that even clear? Like, you pretty much have to dig through the documentation for whatever network you're looking at.
I don't think most developers, really only wallet developers need to worry about that, right? Like, how many Ethereum developers know what type of signature Ethereum is using? You just need to know, like, basically the EVM will tell you. Like, if you're in a transaction, then it's already been that transaction is associated with a valid signature. If you're trying to validate a signature inside the transaction, it provides kind of the tools for that. But generally, I think
it's completely outside of that. That's right. Yeah, it's really between the user and the network.
Well, I guess it depends what we're talking about, because I think a lot of these assumptions are made because we have a single chain execution. Because when you look at the Cosmos and Polkadot world, there is a much more plurality to this. Therefore, it's not as clear. Therefore, there's a bigger explicit requirement when you actually sign something to actually define how you signed it. And this is also very true for the decentralized identity world, where DIDs actually tell you exactly the algorithm or the curve that was used to sign something. So from an Ethereum perspective, it seems very easy because it's 256K1 for everything, and there you go. But for actually a more heterogeneous multi-chain world, this is not as clear. So there needs to be this kind of prior knowledge that for a specific input, you will get this output.
So I guess the challenge there, and again, I'm not as familiar with how those systems work, but one challenge is, how do you map different accounts and different signatures across chains? So I was talking about kind of how these current layer 2s are trying to do this kind of awkward mapping of between one signature type, basically mapping an Ethereum account to whatever signature type they're using on that layer 2. First of all, do systems like Cosmos and Polkadots have more standardization amongst kind of tying identities together of various signature types?
I don't think they try so much to translate an identity from one system to another, because it does come with these challenges, and that's why the IBC focused so much on the call data between two systems. So I think that to some extent, whenever we actually build these layer 2 systems and we try to almost hide the fact that the user went a layer up, I don't see it as a feature. I actually think that there should be a more explicit display of this context change, in my opinion. And I remember at Connext, there was this conversation about whether or not we should maintain the same address system as the Ethereum, or should we actually have our own? And we ended up setting on having our own with a prefix that actually indicated the name of the system. And I think that's something I actually like about, for example, the Cosmos Hub, where all the addresses are actually prefixed with Cosmos. So you have a very clear distinction between an address that's on Cosmos or not. While on Ethereum, we have this assumption that there's a 20 byte X address with 0x, but then we have no indication of what system we are. Are we on NextEye? Are we on a layer 2? Are we on mainnet? Or are we on Robston? We have no idea. So that's where I started realizing that accounts are not addresses. Addresses are just a reference to an account, and accounts are actually the conjunction of chain ID and an address. So we should actually push for a world where we actually have a much more clearer expression of accounts through a chain ID appended with an address.
This reminds me of the assumptions underlying DNS for a US-centric world where domains like .com and .edu have become permanent fixtures, but those are actually just for United States use, and most other countries have their country, they'll have like .co.uk, those kinds of addresses. So we do have an opportunity here to not make the world in a Ethereum-centric world, and try to.
And that metaphor is Ethereum the US of the blockchain world?
Yeah, no, I think there is that happening, and as other blockchains adopt Ethereum or EVM, it's really EVM standards. They bring those assumptions with them. They have 0x in the address. There's just so many things like that, and that we're going to have to break, because we've grown up in this country, and have all of its assumptions all throughout our tooling and user interfaces and everything.
So actually,
funny idea of Ethereum exceptionalism.
The European Union actually worked for a lot of years trying to standardize the banking system across all of these countries, and that's where the IBAN number actually came. And for a lot of people who actually went through that transition, it was actually very easy, because what they ended up doing was basically padding existing account numbers from national banking systems to a specific length, and then prefixing it with a country code. So everyone just kept using their banking numbers as before, and then just prefixed with an IBAN country code, and that just became the European banking number. And it was actually that easy. I remember I was in Portugal when that happened, and I basically just had a banking account, and I would just put PT50, and that would be my IBAN.
Funny you bring, I guess, this whole problem up. I remember in 2016, just a few months after Ethereum launched, there have been so many proposals to fix the address in question. And there were proposals this was even before the checksumming came into life. And the checksumming was a result of that discussion. A said result in the sense that there were much bigger changes proposed to have like a prefix and include more data in it. And the checksumming we have was the least amount of changes required, because it didn't require any dApp or wallet to change. It was an optional opt-in solution. And even back then, the nicer solutions were rejected out of fear that nobody is going to adopt them. And regarding the IBAN, funnily enough, there was a IBAN standard for Ethereum addresses. The downside it had is that IBANs do have a length limitation, and if you want to adhere to that limitation, you could only use, I believe, roughly 248 bits, probably 250 bits is what you can encode in them. What that meant in practice, you had to keep the first byte of the address always 0. But some older tools still support all of these. Anyhow, what I'm trying to say is that even early 2016, people were afraid to make such changes. And throughout the years, I've seen always this reluctance to change something old, or something which is working, and try to make it better out of fear that nobody is going to adopt it.
So I've become a little obsessed with standardization because I just felt like that was the only path for anything meaningful to happen. That wasn't just raising $10 million and just building everything proprietary. And I think that what I learned obviously was that, as you said, the least change you can cause to the majority of the stakeholders, in a sense, the more likely your standard is to succeed. So standards need to take into account existing market conditions, whether there is a lot of participants who have huge costs to change to actually implement a good standard. And it's in my opinion that the best way to actually tackle these problems is at the interface layer, because I don't even expect any changes at the protocol layer or even at the smart contract layer to change of how addresses actually work. And that's why I'm so keen to bring so much standardization at the JSON RPC layer, because that's where the interfaces meet and we can actually build more expressive systems. So with that, with all of those initiatives that I tried to push for standardization, it came this organization on GitHub called Chain Agnostic Standards or Chain Agnostic Improvement Proposals, which is kind of a superset of Ethereum proposals that can cover not only just Ethereum, but also Cosmos and Polkadot. And we can actually build multi-chain applications in a way that's designed to not be biased towards any of the systems. And that's kind of where, as I published on this chat, this idea of account ID with appending chain ID, which tries to utilize existing standards, like, for example, the EIP 155 with the chain ID to an Ethereum address to actually provide context about the chain that that address refers to.
And Pedro, do you mean though that current standards that are Ethereum centric would be modified slightly and brought into this chain agnostic set of standards?
I feel like the chain agnostics tries to kind of inherit standards from each system in a way that it's not entirely disruptive to the systems themselves, and it tries to stay as biased as possible to one system. So a lot of the participation right now, it's more Ethereum and Cosmos, and we're starting to see some development from the Filecoin side as well. And a lot of the standardization comes more, like I said, on the interface application development, where we actually can have a system that, an application that targets both an Ethereum or a Cosmos system without having to have either Ethereum or Cosmos change, but be able to design the application in a way that it's reasonable for both a wallet and an interface to support both. And we started with defining how chain IDs are formatted and resolved for different systems. Then we started looking into account IDs. And then I saw that a clear evolution of all of this was, how do we actually take this kind of intent to actually target a JSON RPC request to one system or the other?
Yeah, the discussions in 2016, they weren't proposing to change the actual system. I mean, that was off the board even then. Rather to give a recommendation for the different wallet providers, including MetaMask at the time. I've been looking at your link, and yeah, it seems like a really good approach, trying to tie in the existing standards, but all of this is again up to adoption.
This is all amazing stuff. I've been furiously taking notes. I put them into a HackMD file. This is all really great stuff. I hope it could lead to some attitude changes and more, and perhaps even structural changes to how the standard process works and this orientation around Ethereum. that isn't entirely appropriate given how we're heading toward L2s as a bridge, really bridge for the ecosystem until Ethereum 2 or something else can support the massive transaction loads that are ahead and complexity that's ahead. So it's interesting that I think it's really interesting that the Polkadot and Cosmos ecosystems have had to address this out of just for their own strategy and also their own premise have begun addressing these, and others as well. But this is really interesting now that L2 is the way out through this craziness we're heading into. I mean, DeFi has really given us a taste, and of course before that the massive bubble and ICOs and things gave us a good preview. But over summer, the DeFi summer really taught us that we have serious problem, and L2s are looking like the stepping stone. But it's forcing us to address these old issues of Ethereum centric universe versus multi-blockchain.
I want to use that.
Oh, you mean?
I just think that's a good word to kind of encapsulate.
Yeah, I know.
some of the issues that have been baked into Ethereum, and some of it just because as the first mover and something that was built, but a lot of the lessons have been learned from Ethereum. So, but we're maybe at this point where people are like, oh, a lot of people only know Ethereum. It's like, well, people might not see some of these issues we're facing because that's just how Ethereum is. So I think that's funny. If we're up for switching gears a little bit, there's some interesting discussion in the chat around business models for layer 2s. Anybody have thoughts on how these projects are going to fund themselves?
I think probably the one that comes most to mind is Optimism is looking into basically like leveraging the miner extractable value outcome. If you've never read that paper, it's called Flash Boys 2.0 by Phil Diane and et al. And so like the idea that you as a validator on one of these layer 2 frameworks get to decide block transaction ordering in blocks when you do block synchronization can be used as a way to make money. I don't know if those frameworks specifically have a way to tap into that as a business model, but we're already starting to see this miner extractable value outcome play out. Several mining pools have integrated private transaction pool functionality where you can pay a premium over your transaction cost in order to get your transaction into a private mempool managed by the pool, by the mining pool managers. So I think there's a lot of interesting ways to play with that, and just interested to see what's ahead. It's obviously a hard problem trying to design public goods with sustainable business models, but there's a lot we can play with here.
It seems like MEV is kind of one of the common themes that a lot of these projects say that, the block producer is a bit of a privileged position, that they're all going to take advantage of that. And I guess it's a little funny because it means they're kind of going to like front run their customers, I guess.
Yeah. And I think a lot of people actually get like the result wrong. They think it's like this like malicious thing and, like everyone's going to be like paying the miners like mob bosses or something like that. But like really it's turning into a really interesting thing because the arbitrage opportunities around like when somebody makes a big trade, you can kind of get in and get out before and after them and able to actually take some of their trade away from them by doing that with a public mining pool Now with a private mining pool, that won't be possible. So it is a feature, people really want, because you don't want your trades to be taken from you or siphoned from you in some way. And Ethereum's lack of support for like privacy at the base layer is the cause of that. And I think like layer 2 frameworks, you'll see like each layer 2 has its own system for how it manages block mining and all that kind of stuff. So you'll see different systems grow from that. I think the only thing you can really say for sure is that each layer 2 framework's validator pool or mining pool is definitely going to be smaller than what Ethereum's is. So there's more of a chance to play with that,
For rollups, many of them don't have any kind of validator mining pool. It's basically a single entity.
So somebody has to push it. So even ZK rollups, like somebody has to like for ZK rollups, for example, you have a series of transactions pushed. Somebody has to go and mine them, quote unquote, by combining all of the transactions together and providing a validity proof, which is on that series of transactions as a zero knowledge proof that can be validated on Ethereum as a way to commit that.
But I believe for most, at least for rollups, that there's not much benefit to having a pool of validators. Now, I believe anyone can be a validator, but typically there's a single entity that's like kind of the privileged validator.
Is there a single node that actually completes a rollup, or are there multiple nodes completing a rollup at once? And then
I think we'll see multiple. I don't think a single, like it won't be robust if it's just one node, because if that one node goes down, then everything is lost.
Well, I think
not everything's lost, but
not everything's lost because it's all published on chain.
Yeah, but like like you lose the future capacity. Like it doesn't continue if it's all one node.
So it's one at a time. Like in these cases, it's like one. I guess what I meant was that there isn't a single node receiving the transaction, but that that there might be multiple rollups in process at the same time.
Yeah.
You mean multiple nodes on the same rollup or multiple separate rollups?
In those two models, I wasn't sure which one is happening, or if there's different approaches from these different networks.
I might be wrong, but I'm pretty sure most rollups have a single node, a single operator. I think anyone can submit. I wish I knew more about these consensus rules and stuff. But I believe anyone can submit these proofs, but that there is a single entity that does have like a privileged position to generate these nodes, and that probably ties in, I guess, to the business models that these companies are building rollups, kind of giving themselves a privileged position. But even though that they're privileged, there's still no security assumptions that users still can, exit at any time trustlessly, or they still can, I guess, kind of run nodes in the case that central operator decides to stop validating.
Yeah. I think, there's like transaction fees that'd be accounted for, and then there's like, at least most of them have some mechanism of saying, like, you're not doing the job anymore, we have to switch you out. I think optimism falls into that. Yeah. It's interesting, though.
And in terms of the privacy-oriented networks like Aztec, how does that fit in? Like, have they removed themselves from that business model entirely? I'm assuming they would. Yeah. And how are they going to? Are they just going to depend on?
I'm not as sure about Aztec because, as far as I can remember, Aztec is like a proprietary protocol. So I think you'll have to buy in like an SDK key or something like that. So they have a more traditional business model there from a software perspective. I'm not sure about that. That's just my recollection.
I think they've also shifted their. I remember I read up about them a while ago, but I think now that rollups have come out, I think they've adjusted a bit to be more rollup-like. But I'm not totally sure.
Yeah. I was just remembering the actual software they built is proprietary.
Closed source.
Yeah, closed source. Yeah. So they're yeah.
But I'm wondering if there's even an approach in this, if in a privacy-oriented network along the lines of what Brave does. I might be just stretching. I might be. This is just a complete going out on a limb and a stretch, but how Brave uses statistical inference to preserve privacy, but still provide some data for advertisers. I'm wondering if there's some approach in there.
Yeah. I mean, one thing that's really interesting, especially if you're talking about like financial markets, is the ability to sell like market intelligence data for a lot of money. So if you're one of the few that are actually like in the loop on all of the transactions that are happening, then you can potentially sell that like financial intelligence data from you running the roll up or something like that, and be able to sell that to people for a fee or something like that. If you built like a Bloomberg terminal kind of thing.
Just gonna pop out another kind of little out there idea about possibly the future of like rollups in L2. I'm guessing, right now we see things like Binance Smart Chain. We see, sometimes when a business or other entity wants to kind of spin up their own chain, have a little bit more control of it, and maybe, offer some benefits like low transaction fees or something like that. My guess is in the future, we're going to see more and more entities like that want to kind of have their own chain instead of just spinning up a completely new chain, that they'll do either a roll up or something like a parachain, or I forget the equivalent on Cosmos.
Yeah, but, I've definitely thought about that too. Like you can imagine like a brokerage or something like that. They're not going to post all of their activity on chain. They're going to manage it themselves, and then they can use these same systems to do the interactions, because they don't necessarily have to be open to work.
But they still might want to be plugged into the larger financial system. If you want to have your own, maybe even semi-permission chain, but you still want these assets to be able to flow back into Ethereum and go through Uniswap and Aave and things like that, that this is a good approach to that. And I think it'd be really interesting if we saw a CBDC that decided to. I know a lot of these CBDCs are working with Consensus and other Ethereum ecosystem companies. It'd be cool to see a CBDC launched as an Ethereum rollup.
Yeah. I mean, yeah, that's the reason why I think one of the use cases we'll probably see supported is like just money transfers, because like that's really for a CBDC, and then like you can use the layer 2 for the money transfers, and then you can actually have money move in and out of the layer 2 in order to access the financial markets of Ethereum, and do other things with that.
This fits over on the baseline protocol as well. They're trying to create ways for enterprises to integrate with blockchains while preserving a lot of their databases and information. It's interesting. I wonder what they've done, what kinds of what kinds of connections there are here with the problems we're looking at for L2s. Like, what are they solving? What are they addressing? Part of me looks at that and I just see enterprisey stuff, and it looks a bit intangible. But they do have, I think there's 2 implementations or 2 experimental networks. So I think in partnership with Azure.
So we're coming in at about 2 hours now. How long was this going to go for?
Oh yeah, this was only a 2-hour thing. So yeah, we should probably wrap it up soon.
Is there anyone else in the chat that had questions?
Yeah, this is a good time for a final couple of questions. All right, cool. I guess not. I'll post my notes. I've been taking notes furiously this whole time, so hopefully I've done an okay job of it. I'm going to paste them into this HackMD, and then I'll link to it on the Magicians Forum. Okay, here's a question. What is optimism? That's a big question. We could just put a link to it. Yeah.
Optimism
I
is-
added a link. So it's an optimistic rollup framework that Carl Florsch and some other people are working on. So the difference between optimism or optimistic rollups and ZK rollups is that optimistic rollups use what's called a fraud proof. So when you do a withdrawal, you basically leave a space of time. I think 10 days is what David was saying. And over that time, you can submit a fraud proof to show that that exit was fraudulent. And then the assumption is that if no one posts that fraud proof within 10 days, it's probably okay. So we're going to settle it at that 10-day mark. Now with the ZK rollups, what you actually submit is a validity proof, which uses zero-knowledge proofs to prove the validity of the state transitions in a submitted block, to say like everything that happened inside this block is correct as long as the zero-knowledge proof framework is all good. Everything in here has worked correctly, and we can assume it's true. So that's kind of the difference between the two approaches.
You can basically think of ZK rollups as pinpointing state into the layer 1 chain, while the optimistic rollup, it's more having a dispute time period where you can dispute the state. But that comes like with its own drawbacks, because I don't know. I feel very split. I really like optimistic rollups because I think they're more viable, but there is this kind of inheritance of security that ZK rollups has, but it also comes with the exotic cryptography, in my opinion, which is a drawback.
Yeah, you have the trade-off of the cryptography, but you have faster settlement rates, and then the other way is economically assured. So it's less complex, but it does have that settlement period, which is the on the con side.
I think
they're also cheaper and more scalable. The optimistic is cheaper and more scalable than the.
Yeah, and they also can be run, kind of the ZK rollups require running basically servers to generate these proofs typically, whereas optimistic rollup you can run on a laptop.
Yeah. One thing with the ZK rollups is they're actually looking at GPU mining with that, which is really interesting.
Then you have like this kind of like comparison where you could say that a validator or a prover on the ZK rollup and a validator on the optimistic rollup, it's almost the same as on the optimistic rollup is proof of stake, and on ZK rollup is like proof of work, because one has hardware requirements and the other one has capital requirements, but they end up being somewhat the same, economically speaking, for the validators.
These are great. These are just great contrasts between these two systems.
I guess my question about the capital requirements, you said there, what I'm thinking of is the dispute, or in the case of fraud or something like that. In the case of a ZK rollup, the user needs to generate their own ZK proofs and post those as a dispute. Whereas, and that of course requires, most users, that basically means you got to go rent some really beefy AWS server or something like that. For an optimistic rollup, you can just run a simple light node and post a single on-chain transaction. So I don't see the capital.
And that's why no, the capital requirements is for the operator of the rollup, not for the user. Yeah, but that's why I find
do ZK rollups have those as well? Are they required to post collateral?
No. Because you are able to compute a zero-knowledge proof. That's your collateral.
Gotcha.
It's like you were able to even complete that operation. You got it. You can operate this rollup.
That's an interesting metaphor of kind of proof of work versus proof of stake.
Yeah, but if you think about it, like the operators end up having the exact same cost. It's actually the decentralization comes on the user side. It's not so much on the operator side.
Could you elaborate on that a little bit?
What I think that the decentralization that David was mentioning is more in the sense that to be able to interface with the ZK rollup and optimistic rollup, it's easier with the optimistic rollup because you don't have exotic cryptography. Neither you need a lot of hardware requirements to even validate yourself. While with the optimistic rollup, it's just a BLS signature. It's very simple. But for the operator side, while in ZK rollup you do need this hardware requirement, on the optimistic rollup, the operator also needs to have the stake in place. Otherwise, there's no way for it to get slashed.
There's always a stake one way or another.
Yeah, it's either a hardware or a capital one.
Yeah.
So this does
That's why I like the ZK
POW
rollup,
versus POS debate.
That's why I like the ZK rollup, though. It's kind of like proof of work. You know, like anyone can do it as long as they buy the machinery.
What I like about the ZK rollup more is the fact that you could do L1 to L2 transfer or a call data, which with the optimistic rollup would need a third system like a state channel to execute. You know, with the ZK rollup you don't need that because there is.
Can you elaborate on that? Why you're saying for any arbitrary L1 to L2 messaging?
Yeah, because every time, for example, like whenever the podcasts happen on this debate, I think I've listened to every single one of them between Alex and John on this, and it's very interesting. They both have very interesting points, and I side with optimistic rollups simply put because you could run them on a phone, but the ZK rollup has this ability that you have the validity proofs on L1. So you could, by proxy, interface with the L2 by just being on the L1 because the state is already there. While on the optimistic rollup, from an L1 perspective, you're basically declaring validity of the state by the lack of the fraud, which is basically saying because nobody told it's a lie, therefore it's true. But there is a tax to this, and even if you were to run your own rollup nodes to actually get the state and hear from the other peers whether there are fraud proofs, then you have like Eclipse attacks and stuff. Like the networking requirements are also there, where you have to be a very good maintainer, a node operator, to actually ensure that you do get fraud proofs if they do get broadcast. Or maybe they just didn't notice, which is very unlikely, I believe. There will always be enough stakeholders in a rollup to actually detect them. But in the ZK rollup, you do not need to have this monitoring or watchtowers, in a sense.
All right. Well, we should probably conclude this. This is just a great conversation. I'll get these notes ready. I think this could really have a big influence if we get the right people to take a look at this this conversation, and definitely each of you individually bring what you've learned to your teams and try to bring these ideas out on Twitter and elsewhere, and especially on the forum, the Magicians Forum, any place where we can get a deeper conversations or deeper threads going on this. These issues are so critical, and they're old. I could see that so much of this there's a lot of history behind it. So I definitely would encourage you all to do that. And thank you for coming to this. This has really turned out well. We really appreciate it.
Thank you so much all for coming over. And I'm just posting a link to account abstraction call that is going on right now. So feel free to join that if you want to join, if you want to listen to that call, so we are up there as well. And thank you so much all for coming over, and have a great day. And bye.
Bye.
Thank you so
See you guys
much,
later.
just for coming
Thanks.
over. We will
Thanks,
post
everyone.
everything to
Bye.
my forum. Bye.
Thank you all.
Thanks. Bye.
Bye.